As the world continues to develop, technology plays an ever greater role in the production of products across the globe. The impact advancing technology has had on the manufacturing sector has been profound and will only continue to increase into the future. To prepare for the accelerated role of advanced manufacturing into the future, educational programs have adopted new curriculum to prepare students that embrace the required skills needed for the ensuing future of manufacturing. Today, we will be going over our group's progress learning these skills in the projects we have completed. In Lab 1, we learned the basic steps used to operate the Doughbot. The lab focused on learning the relationship between coordinates and the movement between links and joints of the robot. We learned the basics of coding and making flows in Doughbot Vision Studio and movement commands such as move J, move L, and jump. We also learned how to put in move points for the robot and how to turn on and off the suction cup. With this lab, we were able to tell the robot to move to one location, pick up a cube, and travel to another location and drop the cube. In Lab 2, we continued to develop our skills and to learn about image processing, feature matching, and calibration of the Doughbot. In the first video shown, the robot is using an IR sensor to tell when a block is passing past a point on the conveyor belt. When the block is detected, the robot goes to the predetermined point and picks up the block, moving it to another location. Next, we learned about feature matching using the Doughbot. For this part, we used features of an object in a picture to create a template in which the software can identify other objects with the same features. In this video, we have the robot identifying two objects, a lock and a cube, and finding the distance and angle between the objects. The next task expanded on this and used the camera and gripper to sort out blue cubes in a mix of various colored cubes. Moving on to Lab 3, we learned about communication between the two Doughbots known as handshaking. In this example, we were paired with another team where one group was sending a signal and the other group was receiving. The point of the task was for Doughbot 1 to move to one location, pick up a colored block, and place it at a new location. Doughbot 1 would then send a signal to Doughbot 2, and then Doughbot 2 would then move to the second location, pick up the second block, and place the block at an end location. The IO function and IO function input commands were used to allow the Doughbots to communicate. In the last example, we expanded on our understanding of feature matching by matching rectangles onto rectangular slots on a puzzle. The matching used the shape of the rectangles and slots rather than the color. The next step was being able to rotate the rectangular shape onto the slot. In preparation for this step, we used a checkerboard to calibrate the Doughbot in order for the Doughbot to convert image coordinates onto physical coordinates. By programming the end effector to rotate the correct amount, our group was able to succeed in this task. This task made use of fast match to match the rectangles and shell modules in order for the program to get the rotation of the end effector correct. Now, Grace will explain the final project and how we used our knowledge from the first 3 labs to complete the task.
Our final project took all of the skills we learned in labs 1 through 3 and combined them to complete a single task, which was completing a children's puzzle. This task was broken up into 2 parts. The first part included having the robot pick up the correct letters out of an assortment of letters, and then hand them off to the second robot. The team coded the robot to be able to first identify all of the blue letters, since that was the color of the letters chosen. We did this using color extract, image morph, and blob functions. The RGB values had to be customized due to factors such as lighting and camera quality. This was important to make the blobs distinct shapes. Next, using the feature match function, the robot was able to identify which blobs were correct letters. Our letters were P, I, and G. One of the challenges we faced in recognizing both color and letter was the camera setting. FastMatch required the camera to be in black and white, while the color functions needed the camera image to be in color. We were able to first run the code in black and white, create the feature templates, and then change the camera to color and rerun the code, which then used the feature template that was already created and saved in the flow. This made it possible to find the correct letters. After identifying the correct pieces of the correct color, the robot arm moved to the calibration points of those letters, picked them up using the suction cup, and moved them to a position that was inside of the camera's view of the second robot so that it could complete the next part of the task.
For the receiving end of the code, the process functions in a similar manner to that of the sending code, but in reverse. The code starts by setting up a code block that receives a signal from the sending robot, which then triggers the camera. Once an image has been taken, a fast match is run on the image for the first letter P. Once the code finds the P in this workspace, it sends the location of the match to further points in the code. A second fast match is ran on the corresponding hole in the puzzle where the letter goes. The code then tells the robot to move to where the letter is, pick it up with the suction cup, and then move it to the corresponding hole. This process is then repeated 2 more times to get the 2 remaining letters.
Using what we have learned, we were able to successfully complete the final project, with our Dobot being able to handle the send signal, and receive tasks. Thank you for watching.